Hey guys, hey guys, I need to stop saying that. God. Hopefully this stream is coming in okay. I've added in the chat so I can see what's going on. Of course, there's a delay, so I won't know when it's working or not, but if you can give me a thumbs up or something if it is working, that would be great. Today we're going to be looking at some low power stuff, so low current consumption stuff with the ATtiny 85. The reason I want to do this is because of my little ESP8266 or the ESP-12 outdoor temperature sensing thing. The ESP can go down to about 30 microamps in sleep mode, but I also want to use a regulator with that, and that uses a bit of current, just quiescent current. I could change the regulator on the board and like manhandle a different type in there, like the HT7333, which I've got some of, but it's a different pinout to the ASM1117, so it's not a straight replacement. So I thought, why not use the ATtiny 85, which can use the battery power as is, as a method of turning on the power to that regulator using something like a BS170, is it an N-channel MOSFET? I'll look it up. But yeah, so that's what I aim to do, is trying to get the lowest power possible from my ATtiny 85. The watchdog timer on the ATtiny 85 can only go to 8 seconds. Oh, it is working, that's good. So it can only go to 8 seconds, so we're going to have to wake up, add something to a counter, and then keep going, and then build that wait time up to about, I'm thinking 30 minutes for this test. Before I was doing it on 20 minutes because I didn't know how long the batteries would last, but it ended up lasting a month, and that's too long in an experiment, really. So, oh no, wait, the other way around. It repeats too quickly rather. Oh, I'm tired. Sorry. So it needs to run for longer, essentially, and I don't need the temperature to update every 20 minutes. I need it to update maybe once an hour is probably fine, which means that the experiment can run longer, which is good. But it's bad in terms of YouTube because I can't show you the results of the test unless I reduce the capacity of the batteries, and then we can look at it in a different way. Instead of looking at the 2000 milliamp hour batteries, we'll be looking at something that's perhaps 800. Maybe that's a better example. But what we've got on the bench here, this thing here is our ATtiny 85 hooked up to an Arduino Uno, and I'm using the Uno as an ISP, an in-system programmer. So it's going to program my chip for me. Now, to do that, if I just bring up the page, I'm using the high-low tech page. It's a bit difficult to get on the screen here with all this stuff going on. Now, this is pretty much my Bible when it comes to doing programming with the ATtiny 85. I made a video using this page a long time ago, and it's still relevant today, so that's what I'm using. For the low power stuff, there's two sources of information that I'm using, one of which is this one called Technobloggy. You can see the part of the URL here, show KXO, and they've got some really interesting information in here about the different sleep modes. But we're also going to be referring to this dude's stuff, which is Neil Gaiman, Nick Gaiman, sorry, there he is. And he's got some brilliant stuff, so hopefully we'll be able to use some of his stuff as well. He's got ridiculous amounts of tests, so I don't need to replicate these. So you'll see that he's doing it with an ATmega 328, but the principles still apply. So we'll be looking at some of the sleep modes. Sorry, there's some comments I should quickly read. How do I get to the comments section? Oh, there we go. No right audio channel. Oh, that's true. It's a mono microphone. Let me see if I can alter that in here without resetting anything. Properties, or maybe filters. Add a filter, no. Properties, no. Settings, is this going to break everything? Audio, channels, mono. Does anybody know if I restart? In fact, I'm pretty sure I can stop the stream and restart it. So bear with me a second. I'm going to stop streaming and then we'll come back with better audio. Right, did that work? You're going to have to let me know. Okay, good. Well, what I've done is switch it over to stereo, so hopefully that's fine. Yeah, Nick Gaiman's got some really good stuff. It's slightly beyond me, I have to admit, but we're going to start with our blink example, our blink sketch, and we're just going to blink an LED on the ATtiny 85 just to make sure it works. So what we've got first is LED built in. Now we don't want that because that's pin 13 on most Arduino boards. Now I've got one hooked up to pin 2 on here, and I think that is pin 3 in the Arduino IDE using the ATtiny core. So the library that I've got included, let's have a look, file, sketchbooks, let's just go down. They need to find a different way of having these libraries so you don't have this scrolling list, because people have a lot of libraries included. Oh, no, it's not libraries, it's in the board manager, of course it is. So board manager, yeah, it's the ATtiny core is the one that I'm using. So in the ATtiny core, I believe it's specified as pin 3. So let's upload, actually I need to burn the bootloader first. So ATtiny, we've got the ATtiny 85 selected, CPU brownout is disabled, brownout detector is disabled. I don't know what LTO is. We're selecting the ATtiny 85. We're going to go for the 1 megahertz clock because it requires, well, it will enable lower power on the ATtiny 85. It doesn't require as much current to keep that going. We're going to select port COM5 for the Uno, and program is Arduino as ISP, and then we're going to burn the bootloader. Now, burning the bootloader doesn't really, I mean, I could upload a program to it, it's fine, but burning the bootloader sets the fuses on the ATtiny 85 so that it sets the clock as 1 megahertz, it turns off brownout detection, that kind of thing. Yeah, no, you don't need to upload the bootloader, but you do need to set the fuses. So as far as I know, uploading the bootloader sets the fuses, whereas uploading a program just programs the memory and doesn't set the fuses. That's, as far as I know, that's how I understand it. So we'll just upload Blink, and you should see there's an LED somewhere around here. Okay, so it's working. I'm going to bring up chat again, sorry. So someone says, are you going to be using low power dot powered down 8 seconds ADC off, brownout disabled, brownout detection off? No, I think low power is the low power library, isn't it? I'm not going to be using a library for this. I'm going to be just throwing in code to make it happen. So let's have a look at the Technobloggy article, and we'll be able to see what we're going to start with. How do I make this window smaller so I can see what I'm doing? There we go. Okay, so I just wanted to make sure you can see the window in here. So this article is on Technobloggy. It's about ATtiny 85 low power stuff, and it's like an alarm. So it sets off this buzzer and it blinks an LED. And according to this, it gets it down to at 1 megahertz. It'll go down at 5 volts. It'll go down to 0.5 microamps, so 500 nanoamps, which is fantastic. It's much better than I was achieving before. I was averaging 2.5 milliamps. That's partly because of the regulator on the board, but also because the ESP, or the ESP-12 will run at about, actually it says in the datasheet, let's have a look. So the datasheet, this is the datasheet for the ESP chip, and it says these are the different sleep modes. So the sleep mode I was using was deep sleep, and that will give us around 20 microamps. So that's a fair whack more than 0.5 microamps. So I think the ATtiny 85 turning on the power to the regulator is a fair approach to take. So if we jump back to this, it says it will go down to 0.5 microamps, so I thought we'd give it a test. Now this is the program that they're using, which is a 15-minute timer. I don't need to copy their program exactly, but we can take some of the things out of it. So we've got some definitions here for functions. We've got ADC disable. Now the ADC, according to Nick, somewhere down here, so he says turning off the ADC to the analog to digital conversion, the power consumption drops a large amount, down from 335 microamps to 0.35 microamps. So it's 355 nanoamps, which is incredible. So we'll try that, and we'll also use their sleep function, I think. But I kind of want to use the watchdog timer for this. So we might mess around with this code a bit. So let's bring in Blink, and we'll have a look at what's going on with it. I probably won't use, yeah, I'm going to be using the watchdog timer. I'm going to use the 8-second watchdog timer, I think, and then build up from there. I think so. I mean, I'm not massively educated in low power stuff, but we're going to give it a go. Robert says that he just bricked his ATtiny 2313. I've got a couple of those. I like them because they have UART on board, which is quite nice for an ATtiny. You set the clocks down to 128 kilohertz with an 8 times divider. It's way too slow for the... I'm sure someone told me that you can get it back by using high power programming. Is that correct? That might be something else, but I'm sure it's by using high voltage programming you can change it. Yeah, the low power library is quite good, but I'm not using it at the moment. So we want to start off. Let's copy a few things from here. So let's copy his utility macros and his inclusion of AVR sleep. We'll pop that in. Let's get rid of, well, no, let's leave the attribution to Blink. We'll leave that in there. We'll paste those in. And Ross says, is it programming through the Uno as an ISP with just the upload button, or is that normal special setup? Yeah, no, it's programmed just through the Uno. So if you look in the tools section, you can select a programmer. If you upload a sketch, which is, here it is, the Arduino ISP sketch, you can change your Uno into an in-system programmer, and then you select your programmer as Arduino as ISP. And what that does is it just, because you've got this, what is it, an Mega 16 U2 or something. It's got a USB chip on there for a USB compatible chip for communication, and it just doesn't bring in the ATmega 328 into the process. It does something with reset, which means that it passes through all that data over to the other chip essentially. I might be wrong in that explanation, but anyway, it's in the examples, and so you can select that as your ISP. I don't know, Robert, you might just be better off buying some new ones. I think that's what I would do if I'd messed it up. Unless I had all the stuff available to change it. Anyway, where are we? We're going to copy a few bits from here. So we want ADC disable and sleep mode power down. So that's good code that we want. And let's pop that in setup. And what else has he got in here for sleep? So enter sleep is a function he's created just to enable sleep and do the sleep CPU bit. That's fine, we'll put that in too. We'll pop that up there. And in the main loop, we have enter sleep just there. So let's bring that out and then we'll figure out where we want it to go in our loop. So how is this going to work? So it doesn't use the watchdog timer. Let's have a look at his sketch again. So his sketch will do setup, ADC disable, so he disables the ADC, sleep mode is set to power down. Then we go into our loop. Our loop does a flash LED while milliseconds minus start time is less than alarm, play beep, enter sleep. So do flash LED while, okay, so it will flash the LED and then after 15 minutes it will sound an alarm. Okay, well we can work with that. That's cool. So it's just so play beep, what's his function for play beep? So it's just doing it for a period of time and then it goes to sleep and doesn't wake up again. So he's got no function here for waking up. Well, that's not a terrible problem. We can figure that out using the watchdog timer, can't we? So all he's doing is making his thing go to sleep. That's fine. I'm just going to add this to the bottom of my sketch. I know it seems really weird, but I want to be able to bring it into the screen a bit more, so we're going to do that. Robert says it's a challenge to try and reprogram it. I get confused with the 2N 3904 and 3906 as well. Right, so we've got our ADC disable, our ADC enable, we've got our enter sleep, sleep enable, sleep CPU. We have, we're starting off by disabling the ADC. I don't know if I want to do that with this actually, because I might use it to read the battery voltage. And then the ATtiny 85 makes the decision whether to wake up again or not, depending on whether the batteries are too low. So we'll see. That's what happened to my previous one. So if you watched the other video, you'll know that the voltage of the batteries was somewhere around 2.5 volts for 4 AA batteries. So these are nickel metal hydride batteries, which will sit at around 1.2 volts for the vast majority of their usable life, around 1.2 volts. So at the very high end, they could be 1.5 volts, and that will be for what, less than probably about 5% of their usable life, less than that, I imagine. And then they start dropping down, really ramping down. But with 4, that happens more slowly when you're drawing less current. So for a fair amount of time there at 1.5 volts or above, certainly above 1.3. So that would, if let's say it was 3 batteries, it's still well above what is recommended for the ESP8266. So, but it can also drop down way further than I want it to. So I'm thinking maybe the ATtiny 85 can read the battery voltage as well. We'll see. But at the high end, it shouldn't read the battery voltage because it will be too high for the ADC too. And any kind of voltage divider will bleed off current essentially, because you're, unless I use it on the other side of a MOSFET or something like that. So maybe that could be the case. Maybe I read the battery voltage on the other side of a MOSFET, record the value, and then tell it to keep going or not. So anyway, we've got our void loop. So let's have it loop for a bit and then enable sleep, shall we? So we need a for loop. For int I equals 0, comma, I is less than 5. So we'll flash for 5 goes, I plus plus. I'm desperately trying to remember the syntax here. So that's what's going to happen. So we're going to flash the LED 5 times and then we're going to enter sleep. Hopefully that should work. Yeah? Oh. Do I need those at the end of that? Let's just compile that because I can't remember. I think I might need these here. No. Primary expression before thingy token. I hate you. I hate you. What have I done wrong? Let's just get rid of all these. I don't know if I need those. I don't need that. I do. It's greater than. Oh no, wait. Don't tell me. I'm just gonna see what. Right, that's it. we're looking in the examples. I hate syntax. So there should be control for loop iteration for in yeah, there you go. So there's that one. Robert's coming out with loads of awful suggestions. He was trying to sabotage me, I'm sure of it. No, I'm pretty sure he was right that whole time. I just wasn't looking at the chat. Ivengi, is that how you say your name? I don't have my multimeter connected yet. I just want to make sure the light goes out. If it does, we'll then connect up our multimeter and we'll see what the value is. We'll move over some stuff so we can get the multimeter in. So let's program the board and see what happens. So it should flash 5 times and then go to sleep, which means it won't flash anymore. Hopefully. Let's see what happens anyway. Three. Oh no, I must have missed some. 1. I'm watching the stream back. 4, 5. Okay, so it got to 4. So while it's less than 5, yeah, that makes sense. Okay, so it did go to sleep, I think. So let's now use our multimeter to test this. So we're going to move things over a little bit. Let's get this other stream bit up so I can see where I'm putting everything. Oh, of course, it's upside down, isn't it? I didn't really think of that. Do you mind it being upside down? It's upside down for you so you could see everything the right orientation. I could probably change it. Hang on a minute. Desk cam, edit transform, rotation 180. Close. There we go. That's better, isn't it? Hopefully it did that in real time. I have no idea. So I need some crocodile clips. I think doing it this way is probably going to reduce the voltage ever so slightly, but you rotated your monitor instead. Okay, so we're going to still power off here, I think. So let's take that out. We'll plug that onto the green cable. So green's there. Let's try and bring that across the multimeter away from everything else. I also need, not black, that's a bad idea, isn't it? Let's see if we can find a different one. All right. Orange it is. I can't see which one's 5 volts. I'm doing it with 5 volts just because my batteries might be at 5 volts for a period of time. So need to swap the probes around to milliamps. We're going to stick it in milliamps first because I know it's going to be drawing some milliamps, and we're just going to view what happens as it happens. So this one goes to the black or ground, so that will clip on there. So that is out on the multimeter and in on the circuit. And another one, I've got yellow, but yellow will have to do. And that's going to the red probe. Pop that over there. And then we're just hooking that onto that. And now I'm going to swing around to milliamps. So you'll see we're flashing away, drawing a small amount of current. And we should drop down to a very small amount of current. So currently that's reading 0.01 milliamps. So is that 10 microamps? I think that is. Right, what we're going to do now is we're just going to disconnect that circuit because we're going to do a cheat. Oh, actually, we can do the cheat without doing that, can't we? So let's disconnect that and, oh no, we'll disconnect it for now. We're going to short these leads out. Someone taught me this the other day when I was looking at this. So we'll put it into microamps. We're shorting the leads out so that we don't have that burden voltage. We'll connect the circuit up. So we're currently in microamps. You can't really see very well, can you? So once this drops into sleep mode, which it has done now, I can remove these probes and we can see what we're drawing. So we're currently drawing 0.5 microamps, which is brilliant. That is very good. I don't think my meter goes down to nanoamps, but that would be 500 nanoamps. That's pretty good, isn't it? So that's certainly a hell of a lot better than the, what was it? The ESP says it could go down to 20 microamps. So someone can do maths, could tell me how much less that is in a percentage. That would be brilliant. But it's an awful lot less. Certainly a lot less of a burden on batteries that might be almost completely drained. Certainly more drained than the voltage regulator would work to. So 0.5 microamps, and we're currently in deep sleep mode without a watchdog timer. So shall we add a watchdog timer in there to reset the chip? I think we should. So I think all we need to do, maybe, this is a big maybe because I don't know. So let's just change this because I don't know how much, that's going to be more seconds than I'm happy with. So let's say flash that for 2 seconds and that one for 2 seconds. We'll do that for 5-ish seconds and we'll set up our watchdog timer. So 40 times less, thank you. I am atrocious at mathematics. I have to write everything down or use a calculator. the numbers, they just swim around in my head. So I can't really do maths very well. And I have tried many times. So we need watchdog timer. Is it underscore enable? I think someone might tell me in the chat, but I think it's enable. And then there's a setting that you can use, which is watchdog timer 0 underscore 8, and then it's seconds, I think. So we'll go with that. And what I think that does, and I'm not entirely sure, we can have a look on Nick's page. He should have it somewhere in here. Watchdog timer. Do you have it written down? Well, let's search. Watchdog timer. No, I can't see watchdog timer enable. I think this is the right thing to do. Not entirely sure. We'll see. So what I think this will do is reset the chip after 8 seconds. And so it will go through the whole setup again and wake the chip up from sleep. So let's find out if that is the case. We're going to switch over to milliamps, and it won't give us a very accurate reading, but it will be perfectly fine. And we need to reprogram this, so we're going to have to put the power back as it was. Oh no, do we need to? I could just short it. Let's see if we can just do that. So let's program this chip. Not declared in this scope. Okay. Watchdog timer. Oh yeah, I need to include watchdog in here. So hash include. I could have just included AVR, couldn't I? But we'll just include AVR watchdog. No. Watchdog timer dot h, and that should compile now. /h watchdog timer. What have I done wrong there? WTD enable. Yeah, I meant 200 milliseconds. I don't know why I said 2 seconds. I did write 200 milliseconds there. So what have I done wrong? What have I done wrong? AVR /WDT. Is that right? Brackets. Oh wait, it's not an O, is it? It's that. It's an O rather than a 0. Right, let's try and upload that sketch. I'll short these 2 leads out, and hopefully it will still be okay to upload to the board. We'll see. Yeah, it looks fine. Okay, so we're waiting for 8 seconds. Yes, it worked. Okay, so we'll leave this milliamp hour thingy on so you can see what it's drawing. So the watchdog timer does increase the current. Let's short those out and put it onto microamps. And then after it goes to sleep again, 6.95 microamps. That's with the watchdog timer enabled. So that is only saving half. Edward, it's not too easy to find someone that's interested in electronics to do a live stream for you. Plus, it takes a lot of their time. So yeah, the watchdog timer uses, over. Let's try that again. 1, 2, 3, 4, and then it's asleep. And it's given us 6.95. So it's a lot more than the 0.5 it had when it was asleep, powered down. So let's just, I'm just going to take the power off that so I don't have to hold that anymore. So how do we reduce the current consumption of the watchdog timer? That's interesting. Ah, okay. Waking from sleep with a timer. Actually, Nick's written something about it, which is good. So let's have a look. What did we say that was? 6.95. He's got 6.54 here, so that seems like it's pretty much the same. So, see an example. TV be gone remote. Is this? Oh yeah, it will scale. Good. We can scale that, so you can read it all. So the watchdog timer to sleep for 8 seconds, the maximum you can set it for watchdog for, and then the LED 10 times. Wow, that's almost exactly what I've just done. While asleep, it uses 6.54 microamps of current. That's probably within the tolerance of my multimeter. So during the watchdog as an overhead of 6.2 microamps. Yeah. Interesting. So how else can we wake it up? I'm happy with 6.2 microamps as the draw current if we're doing it straight from batteries and then turning on the voltage regulator. That is fine by me. It's still a very small amount. If anyone, if anyone's wondering what this is actually, I've got whiskey in here, but I don't have any whiskey tumblers. So it sort of looks like I'm drinking very flat beer, but it's not. It's some Jameson's whiskey. But that was a bit much. What is the percentage difference with a 6.2 microamps compared to 2.5 milliamps or 2.495, which is what our reading was when we tested it with a multimeter? If anyone's good at maths, please tell me that. So I think that's probably as much as I can do. The other thing that we can do is any unused pins, if we ground them, I know it sounds weird, if you ground them, they do draw less, the chip itself draws less current. So do we have any unused pins? There's one. We can test this actually. So let's have a look. We want to be in the microamps range. Let's hook these up again. So I have an unused pin here, and that's pin 2, I think. So we're in, it's asleep, and we're on 6.95, and it made no difference. Okay, all right, just ignore me. It worked on the ATmega 328. Honestly, I'm telling you it did. But maybe we need to enable them as all as inputs or outputs. Perhaps we need to do that. But I'm relatively pleased with the results so far. Has anyone got any advice on... Let's just turn that over to milliamps so it'll just keep running. Has anyone got any advice on how to reduce it even more? 2.6 is about 400 times more than 6.6 microamps. Okay, well that's pretty happy. Yeah, just pure whiskey today. I've taken a liking to it, quite a lot really, and I'm not very good at portions, so that seems like a fair amount to me. Well, not fair, like an unfair amount, quite a lot. Jonas says use an interrupt instead. Well, I could do, but what I want to do is have the ATtiny wake itself up to wake up the ESP 8266. So I need it to be its own interrupt. So I have to use the watchdog timer as far as I know, unless someone else has a different bit of knowledge than I do. Because I'm telling you now, I don't know everything about this. It's not a tutorial. This is me just playing around with it. I think the 555 timer draws in the milliamps range. It's not a really low powered device as far as I know, but let's have a quick look, shall we? And let's 555 timer current draw. Okay, so when current draw is output is low. Okay, there's a data sheet here. We can have a look at this data sheet, I think. Make sure you can all see it. Right, and I'll skip down until I see something that looks remotely like what we're looking for. Okay, so supply current is 10 milliamps. Trigger current, reset current. No, it looks like the standard operating current will be 10 milliamps. So that's a fair amount. I want my circuit to wake up once every 30 minutes. I think that's a fair amount. Possibly once an hour, but every 30 minutes should do. Fine, but someone suggested another chip to me, but it's a tiny little, like a SOT 23, so it's not really breadboard friendly, and I want to be able to do the best I can with the hardware I've got. So we're going to be using just an ATtiny 85. I think it's possible that I could rig up, someone suggested there some kind of RC circuit, but an RC circuit will eventually have its own current draw, so it might be best just to go with the ATtiny approach. 6 microamps is better than the 2.5 milliamps I was getting on the wrong side of the voltage regulator. So and better than the ESP-12 can do even without a regulator. So if you're supplying it with 3 to 3.3 volts or whatever, then it still can only go down to about 20 microamps. So this is good enough. And all we need to do is use one of our pins. So this LED is essentially our trigger pin, and it will be the pin for one of these, which is a BS170. So it will be the trigger for our, I think it's an N-channel MOSFET. I'm going to check now because I'm not sure. Where did my window go? There it is. BS170 is an N-channel MOSFET. Good. So it means you stick voltage into the gate to make it work rather than ground out the gate. So we'll be using that. I think its ratings are good enough. I think that's why I chose it. Let me check. So, gate threshold voltage, turn on time. Drain current. Drain to source voltage. Doesn't actually say what its limitations are, does it? Oh, we've got dissipation there, so I guess that if we could figure that out. So 350 milliwatts at 5 volts. So we'll probably be fine. It's certainly enough. We've used it already, actually, so we know it works. Do you want me to try the low power library? We could pick it up if you like. Where do I find that? Include library, manage libraries. Low power. Ooh. The low power library by Rocket Scream Electronics, is that right? If you let me know whether that's right, I'll bung it in and we'll give it a go. Sorry, I'm just going to scroll back up through the chat because I'm aware that I talked a bit there and I didn't really notice what was going on. Yeah, someone's mentioning the RTC thing again. I don't want to overcomplicate it really. So I could use an RTC with a battery that's on it and use an alarm on that all the time. That's perfectly feasible. But then that's another battery that I've got to maintain. I just want it to be the batteries that I have. I can stick a solar panel on those and charge them up if I want to. Although I guess the real-time clock can keep its memory for years on a little 2032 cell or whatever. But I want it to be simple enough for anyone to pick up and do. And I think if I start including more and more components, it's going to be difficult. Certainly if it's a little module, that might be quite cool, actually, the RTC. So I probably will end up trying it. But for now, I want to try the ATtiny 85 route. Mainly because it can do other things than the RTC can as well. So I can tell the ESP8266, or rather have the ESP-12 tell the ATtiny 85 when it's finished, and it will then, the ATtiny 85 can turn off the MOSFET. And I need it to do that because I don't want to connect the ESP-12 to the battery voltage. I want it just to connect straight to the ATtiny 85, so it's never connected to raw battery voltage, which it kind of would be if it was connecting to the MOSFET. I also want the ATtiny 85 to read the battery voltage as well, so it's sort of multi-purpose. It won't be reporting that battery voltage to the ESP8266. It will, it's just to decide whether to turn on or not, really. The ESP8266 can have a voltage divider on the other side of the MOSFET and read the battery voltage if I really want it to, so that I can maybe say replace the batteries now in part of the report it sends. What else do we have? Yeah, Moritz says you can also disable the brownout detector. That's already happened in I've set the fuses for that already by burning the bootloader from the Arduino IDE. I disabled the brownout detector, so that's saving us some current. Evgeny, I'm not Evgeny, that's probably right, isn't it? I'm not sure how to say your name. There's 750 hours in every month. If you wake every 30 minutes and grab 1 milliamp hours from the battery, even without any sleep current, you're taking up 1,500. Sleep current is negligible. That is true. It is negligible, but the idea is that I would like to use the lowest possible current during sleep, so a tiny amount. I could use the 20 microamps that the ESP8266 uses, but then I have to have a perfect power supply for that ESP8266. With this, I can power it from anything that the ATtiny 85 can accept. So that's up to 6 volts, I think. So I would like to be able to do that, to have battery voltage, a battery power that is above 5 volts at some point, whereas the ESP8266 needs regulated voltage. Some people talk about using batteries that they're called the LiFePO-E. I don't know if that's how you say it, but they talk about using these specialized batteries. But I just want to be able to use nickel metal hydride batteries, cheap, affordable, and easily recharged cells that I can replace when I need to at very little cost, and they're easy to get hold of too. So I think that's the route I'd like to go down, rather than creating a specialized solution for powering the ESP8266. There are other voltage regulators, that's very true, but the setup I have uses an ASM 1117, and lots of people who use the ESP8266 on these little breakout boards, I've probably got one here somewhere, I do, on these little breakout boards, will be competing with the ASM 1117 for the voltage that's on this little board. So they're going to be competing? No, not competing. Maybe competing against the like almost 2 milliamps that it will steal. So I wanted to find a way of negating the board's limitations. And it's the same with loads of these boards, really, these little breakout modules and stuff. So I wanted to figure out whether that would be whether it would be an approach I can take. Ross says Andrew Spice did some great low-powered ESP stuff. Yeah, God, people keep mentioning Andreas, but he did do lots of cool stuff with coin cell batteries. But I want to figure out a solution for the cheap boards that you can get, rather than getting like bare boards and stuff and doing it that way and taking off voltage regulators and using coin cells and that kind of thing. So I want to sort of do that. So I didn't get an answer as to whether this is the right low power library, this one that's on the screen now, Low Power by Rocket Scream Electronics. Is this the one that you're talking about, Jonas? Okay, then I shall install that and we'll look at the examples and see what it does. So if we jump into the examples, let's go down and find low power. It'll be somewhere right at the bottom of this list. Low power examples. Idle wake periodic, power down wake external interrupt, power down wake periodic, standby external interrupt, SAMD21. Do you know I bought some of those SAMD21s somewhere in here? Oh, here we go. So these are, yeah, the SAMD21. It's the ATsamy21 G18A-AU because that's their footprint. But I wanted to make my own Arduino Zero board. Did I do that? Did I heck? I designed the board. I've got it in Eagle, but I couldn't figure out a cheap way of programming it. You need to use one of these Atmel ICE programmers, and they're like somewhere in the region of £50, and I just couldn't justify it for one of these experimental projects. Anyway, we're going to use power down wake periodic. Power down is the lowest power version of powering of sleep modes, as far as I know. So let's have a look at this. So low power, sleep for 8 seconds, ADC off, brownout detection off. That's already done, so don't need to worry about that particularly. So I imagine that this is going to be roughly the same current. So let's throw in our blinky bit, and then we'll be able to see the same thing. So let's bring up that. So in our setup, we want to have our LED, and we also need to put this into the loop. So do something here. So enter low power, and then we're going to do that, and then we'll enter low power again. Okay, let's just check I haven't missed anything out. No, that looks to be about right. So we'll compile that. How do you say your, is it Pietro or Peter? I would love to know how to say your name. If you can type that in phonics or something like that, then that would be useful. But I would absolutely love to get some power to my garden. Just, I don't know, 12 volts, maybe 5 volts would be great. Just permanent power would be brilliant. Oh, we've got an error. Error compiling for board ATtiny 254585. I am guessing this library does not work with these boards. I'm guessing it doesn't. Let's try power down. Let's take off brownout detection because it's set anyway. Error compiling for board. Let's take everything out. Error compiling for board. If I take out this, Okay, so low power does not work with the boards that I've got here. So unfortunately, Jonas, it's not going to work. I don't think they've got that in their library. We could do a quick Google though and find out if they've got an alternative. Oh, I can't spell. Hang on, I can't really see it on the screen. That's better. We know ATtiny 85. Okay, someone has already asked this question in 2011. Okay, so this is, okay, let's just do find ATtiny. Can I use this library with the ATtiny 45? I haven't actually tried it out. Look at the registers of the ATtiny 85, quite a number of different peripherals, not ATtiny 85 series. The ATtiny 85 series is screaming for a library, so it hasn't started working on it. So 2013. I don't think there is support for that, unfortunately. It could have made some difference, Jonas. You never know, and I really appreciate you letting me know about it. So let's just move that out of the way for now. We'll come back to it at some point. So Robert thinks MOSFET approach should be enough. A 10k pull down on the gate would keep the MOSFET infinite off. Playdev48 says, hi, try using an internal 6.4 megahertz RC oscillator instead of the 8 megahertz, and then divide the lower frequency down to get 0.8. I'm using the internal 1 megahertz clock for the ATtiny 85. Do you know, we could try using the 128. Do you want to do that? Let's have a look at that. That might be quite fun, and we'll turn it on to microamp scale so we can see what it is when I take it off. Let's upload that 1.2 kilo. Oh, I might need to, I'm gonna have to burn the bootloader actually, I think, to set the registers. I don't think it does it when you just do that. So we'll burn the bootloader quickly. Error while burning bootloader. Check the invalid device signature. I hope I haven't, I hope I haven't done anything. Let's try it again. It might have just been, yikes. Okay, hang on a minute. Can we just upload? Let's see. Dun, dun, dun. Everything's connected, isn't it? Oh. What is going on? Let's disconnect this and connect that to there. Right, now let's just power everything off for a second, power it back up, and we'll put this back to 1 megahertz and then see if we can program the board again. We can't not. What's going on? What have I done? So I've done something. Well, the Ivengi says, well, putting a crystal onto the ATtiny 85 make the watchdog timer consume less current. Actually, using external crystals consume more current because you have to load those capacitors. So it charges up and discharges, essentially, loading that crystal, making it fire. So it uses more. The internal oscillator in the ATtiny 85, certainly in the 328, use less power. So the external ones use more. But I've now got a problem. What's going on? Invalid device signature. ATtiny 85, 1 megahertz clock. Okay, let's just try unplugging and plugging back in again. You never know. Never know if that's going to work. So, upload to board. I should have checked the port. Invalid. Try double checking the connections or use F to override. What have I done? I haven't bricked it. We can definitely recover this. So let's just figure out what's going on. We've got reset here. I'll tell you what. Let's just... Let's try that again. I can't have bricked it. That's not possible. Let's just put these connections back for a second. I mean, I say it's not possible, it's entirely possible. And we'll take out, that's ground, ground. Where is our pin? There, let's take that out now. I might need to restart the Arduino IDE. Let's do that. We'll save this as Blink 85 or 185, just as a reference to a band I used to listen to when I was a child. When I was a child, it's not even that long ago. Okay, we're just going to close down. Hopefully this will sort it out. We don't need that for loose iteration. We don't need the ISP. No, we don't need that. And we don't need that. So let's try that again. Verbose output would be a good idea, so we'll try that in a minute. So here is our sketch again. We should be on Arduino as ISP. Do you know what I'm going to do very quickly is look, let's just reprogram that Arduino just in case I did something stupid. Tools, Arduino Uno, Mark II. Okay, and we'll upload that. We'll just make our Arduino a, we'll make it an ISP again. Let's pop the thing back in. That's wrong. I need reset, not 3.3 volts. I don't actually know if that capacitor is necessary anymore. It may not be. Maybe you should upload using Programmer. Well, maybe, but the Arduino ISP has worked fine for those other uploads, so I think it's probably all right. And now we will jump to being Arduino as ISP again. You know, those external ISPs are just programmed microcontrollers that fire off stuff, so it's exactly the same. And we want to select ATtiny 85. Brown disable, blah, blah, blah. Do we want to burn the bootloader? I think we probably do. Invalid device signature. Okay. Let's take out the power. We'll also take out the chip. And we'll use another one. There we go. And I want to put that into 5 volts. There we go. Right, let's give that a go. Arduino as ISP. COM5. Yeah, I'll take a look at the verbose output in a bit. Burn bootloader. Well, it's done burning the bootloader, so we did brick that chip. I don't know why. I assume something to do with it being in deep sleep, potentially. Let's power it down again, and we'll put in the other one, and we'll look at the verbose output of it and see what it says. Which one is 5 volts? I can never remember. There we go. Okay. So, burn bootloader. No. Okay. Gonna do a quick Google. Let's see if we can recover it. ATtiny 85. Invalid device signature. Well, this is a common one. Lots of people asking about this. Let's have a look. So this one's from 2012. Let's have a look at the one from 2016 and we'll see what it says. I know you can't see that. I'm just going to bring it over. If it won't, if Windows will let me. There we go. Device signature 0, so that's what people are saying. Uploaded the ISP. Okay, well that one was rubbish. He just had the wires the wrong way round. So let's see if someone else has got a similar problem. Okay, let's have a look at the verbose output, shall we? Preferences. Show verbose output during upload and compilation. So let's upload and we'll look at what's going on. Let's make this a bit smaller, shall we? So you guys can see it. Okay. Hopefully you guys can see this. In backwards, no, it programmed fine and then didn't program again. So it was something to do. I'm going to check though. No, pin 1 is over here at reset. So pin 1 is reset. So that is right. So using COM5, using programmer, that one. Baud rate, baud rate, whatever you like to say. Chip erase delay. Where is our device signature? Zero, 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 zero. So our device signature is all zeros, which is a problem. Double check connections or use -F to override this check. Well, we don't want to override the check. Something's gone wrong. Yeah, I think you're right about the 128 kilohertz. Bit of a mistake. Let's okie doke, let's see. I'm just checking out someone's thing here. They said that they set their clock to 128 kilohertz. So Perhaps we'll be able to save it, who knows. However, this outputs 4 megahertz. Another standalone sketch for the 18mm. Nick's code worked for debricking to the ATtiny 85. Nick Gammon again. Or Gaiman. Right. Standalone sketch. So what does this do? 8 megahertz timer on pin 9. Don't really understand. Let's have a look back. So, I set the fuse on the ATtiny 85 to expect an external clock instead of a crystal. That locked me out of running or reprogramming it. Did I do the same thing? Oh my word, I bet I did. I bet I clicked on the wrong thing. That would be very annoying, wouldn't it? Oh, I'm not doing any 12 volt programming. This guy says that we can do that. I'm using the Arduino Mega to supply a pulse for the clock. So, assuming it's hooked up correctly, you check it against the data sheet for the device, look at that clock on the scope. What core are you using? Right, so I think I'm just going to give up on this chip for a bit. We'll come back to it. I'm not going to do like 30 minutes of reading on stream because I don't think it would be a good idea. Let's pop this one back in. I think this one was the one that worked, so I'm going to get mixed up now. Luckily, I've got about 30 of these, so I have enough to play around with. Let's check that was the one that worked. So we want our sleep. Let's check we're in 1 megahertz internal. Everything is the same, and we'll upload that to the board. No, that was the broken one. So, oh no, it's because I haven't put power on. Let's try that again. Yeah, there we go. So that one is the working one. I'm going to turn off verbose output because it's really horrid. Oh, actually, I can just make it smaller. I need to mark on this chip that it's busted. In fact, I have a little... I've got one of these things. I don't know if this is going to focus. We'll see. Let me bring up the monitor so I can tell. So I've got one of these little microcontroller holders, let's call it that. I'm just going to pop that in there so that I know that that is the broken one. Let's just push that in. Oh, it actually comes out again. I need something to put in there. What do I have? The leg of a resistor. That will do. And I'll just bend that down. Using that. Okay, that's going nowhere. So we'll remember that's broken, and when I get some time, we'll come back and fix it. I need a pen really to write on it and say that it's broken. I can't, but I'll put it aside. So yeah, I'll come back to that. I'll see if I can do some reading and figure out what I've done. So that's very easy to do, isn't it? By just changing the clock fuses, and then you can no longer program it anymore. Seems a bit... I mean, for... The whole idea about the Arduino IDE is that it's easy to use for people who aren't very good at hardware, which is pretty much me, and probably aren't all that good at software either. that it's easy to use and you can interface with these chips relatively easy. But putting something in there that will immediately brick your chip is kind of annoying, isn't it? Why would they do that? Maybe I should have just read a bit more about it before starting, but you can't account for people's stupidity, can you, I guess? Anyway, it's getting late now, so I think I'm going to end the stream here because I've got work tomorrow at 7 in the morning, which is outrageous, I realise. But someone's got to earn the Benjamins, so I have to go to bed, really. So Harry's just deleted his messages. Okay. I don't know what you said there either. Was it rude? It doesn't matter if it was. I don't care. There's no moderator in the chat today, I don't think. I know, Robert. Isn't that terrible? Exactly. I think I did. I don't know. Subconsciously, you put that in my brain somehow. Anyway, it's been fun. I guess we've figured out that we can take it down to 0.5 microamps without a watchdog timer. We can use an interrupt to wake it up down to 0.5 microamps. So maybe we could figure out an external circuit which takes very little power that will wake it up every second or so, and then we'll try and figure out a lower power version of way of doing this. But I think 6.2 microamps or whatever it was, I can't really remember now, is low enough for me to be happy, because I mean the ESP8266 on its own is 20 microamps, which is, you know, orders greater. So yeah, it's better, and it's on the right side of the regulator as well, which is good. So thank you very much for showing up on this zero notice stream. I literally decided to do it about 10 minutes before pressing the live button. So thanks a lot for showing up and for all the really helpful comments. You guys are basically my brain. I mean, I had to ask you to do maths for me, so I'm pretty much very thankful. Anyway, I have to drink the rest of this before I go to bed, because otherwise it's a terrible waste of what is a nice whiskey. All right, okay, Harry. That's fair enough. Oh, Jonas, I wasn't talking about another chip to wake it up, just another bit of circuit. So not necessarily a chip, but some kind of physical oscillator or something, I don't know. But any physical oscillator is not going to work every 30 minutes. So the ATtiny 85 is going to do more than just wake up the ESP12. It's going to measure the battery voltage and make a decision as to whether to wake up the ESP. And it'll also turn it off after the ESP8266 is finished. So the ESP8266 won't be turning itself off. So there's a few different things the ATtiny 85 is going to do. But there was, I can't remember who wrote the comment. I'm going to have to look. There was a comment that somebody wrote on my video for the number 3. I'll have a look what it was called. There was a little, oh yeah, it's called the, let's have a look. We'll pull up the datasheet quickly before we finish. So it is the TPL 5110, which is an ultra low power timer with a MOSFET driver, MOSFET power on, MOS driver, whatever. So ultra low power apparently, and it is, so that's what, 35 nanoamps there, 0.035. I mean, that's at 1.8 volts. If we look further over, 5.5 volts, that's roughly what we'll be throwing into it. So that's the VCC max just there. I can't really, it's a bit difficult to get all in the screen at once, but so programmable watchdog, programmable delay range with a watchdog. So it's in a tiny little like 10 SSOP package or whatever. So it's not breadboard friendly, it's not using at home friendly or anything, but what you can do is have a timer on there and then it will turn on a MOSFET if you want it to, essentially. So I think that's pretty cool. Let's have a look at the datasheet, see if it actually says what the longest timer that you can have is. So selectable time intervals from 100 milliseconds to 7,200 seconds. Let me just try and figure that out in my head, the maths. So 60 seconds to a minute. And that would be 100 minutes plus 1,200, which is 10 minutes, 20 minutes, 120 minutes, 2 hours, is that right? Someone will have to tell me in the chat if I've actually got the maths right. You could probably, with the microphone so close to my head, you could probably hear the gears turning in my head. So yeah, I think that's an hour 20 you can have a selectable timer for. Using 35 nanoamps, which is ace, really, isn't it? I mean, I couldn't make something with an ATtiny 85 that does that. So when I get around to making my own ESP 8266 board, which I will do eventually, and I'm going to design it around the ESP-12, I've ordered some of these and I've started designing a circuit in Eagle. When I do that, I think I'm going to include one of these and have it as a selectable timer. So you can say, I would like a timer to turn on and off my ESP8266. And there's also a done pin. Can you see just there? Done pin. So you can use your microcontroller to say, I'm finished, turn it off, start the timer again, which is ace. So it was 2 hours. Yes! Literally the best thing that's happened today. I'm kidding. So yeah, it's got a done pin. So actually this is a really awesome little chip, but not remotely breadboard friendly, but it would be really nice to play around with. So when I get around to designing one, I will put it in there and we'll have it as an option on the board. So you can, I don't know, move a jumper and this will be powered up and be used. So be a little bit of fun. But for now, we're just going to use the ATtiny 85, the really crappy breakout board that I've got for the ESP-12 that I'm using. And we'll try and reduce that base current need. The current need for the ESP-12 will always be high. It's always going to be around 70 milliamps average when it's making its calls, and the voltage regulator will always need about 2 milliamps unless I switch it out for a different one. So that is always going to be a large amount, but the base rate can be lower than the 2 milliamps, the 2.5 milliamps that it's requesting at the moment. Anyway, I'm done for tonight. Thank you very much for sticking around. I appreciate it. And all the comments have been brilliant. So I will see you all in the next video, which will be coming probably on Sunday. It will probably be another little kit that we're going to make. I've still got loads more, so I enjoy doing that. I've ordered in a bunch more. Does anyone want to see? Getting distracted, obviously. AliExpress. These are some of the ones that I've ordered recently. I can show you on my AliExpress account. Let's see, my orders. Okay, how do I bring this across? Can I just drag a tab? I can. So hopefully this doesn't show you any weird stuff. Okay, ignore the order IDs because I don't know whether you can find my address with this. Who knows? Anyway, we've got a watch. I've got some ATmega 328s. A voice control level indicating voice indicator DIY kits electronics kit. A spectrum analyzer, an LED cube, a DIY audio switchboard RCA 3.5mm audio input block for amplifier electronics kits, a touch delay switch kit, a SMT full SMD multi-channel waveform generator suite SMD weld DIY kits solder testing electronic circuit trading parts. We've got lots of these SK6182s. They're like the NeoPixels essentially. I want to do something with those. Thought it'd be fun. I've got quite a few on AliExpress. Every month I spend about £20 on AliExpress, which is basically all the money I get from YouTube and some of my own money in the end. And then we've got the ESP8266 modules. I've ordered 4 of, oh no, this one's a breakout board. I've ordered 3 of those, the ESP-12. And there's another spectrum analyzer because I've forgotten I bought it because I bought it so long ago. And there's the New LED sound control melody lamp electronic production DIY kit suite in selling. That was the one, that's the kit that I made last Sunday. So there are still plenty more on here probably. So there's some SI 4463 wireless things I haven't got around to using yet. Some infrared sound things, mobile phone signal flash things, a little line car thing. Anyway, there's a lot of them, so there's loads. So I'll be doing those. I want it to make it a regular thing because, you know, Sundays can get pretty boring and I'm quite lazy. So making a kit on a Sunday is quite fun. Oftentimes I'm like thinking about going to work and a kit will make me forget about having to go to work. In the weekday I don't mind working on projects, but Sundays I like to have for just not really thinking. So I've gotten distracted when I was meant to be closing the stream off, haven't I? Only 17 pages, you've got 29. I've also got some eBay ones. I wonder if I can show you that without showing you things I shouldn't show you. Purchase history. Yeah, there's a few on here. Let's see, what is, all right, okay, let's just pull this out. So this is my eBay stuff at the moment. I don't know where it is, where we are on the stream. We're really far behind. Are we? Or I'm just not previewing it right, I don't know. So I bought this, this Paniosonic thing. We can have a look at that. It's, someone suggested I pick one of these up. I'm gonna bring it over here just so I can show you that thing. The Paniosonic AFM radio thing, that's £3.89. But we've also got, oh, I bought some of these tweezer testers so I can do some SMD stuff. I bought another one of these wireless USB thingies. This is so I can tear it apart and put it inside that little LCD monitor thing, or rather the mini TV. This beautiful heart-shaped kit, which is going to be nice. 5-volt USB Bluetooth thing, some flash stick, that's going to be cool. This is a mini Tesla coil where you put music in. It's going to be incredible. And then I accidentally bought some more NeoPixels and stuff, so they'll be coming at some point. Anyway, we're done now. We're done. We are done. Closing everything down. That's it now. It's over. No more of this stuff. Thank you for showing up. I've already said thank you several times, but I do appreciate it. And it is now time to just down this in one. I'm not going to do that. But thanks a lot, and I will see you all soon. How do you stop the stream? Somewhere in here. Okay. All right. Goodbye.